Welcome to BYJU'S Exam Prep Civil Mechanical and EXE YouTube channel. If I am perfectly audible and visible, can you please tell me in the comment box? It's perfect, amazing. So guys, it's a humble request to all of you, kindly share this video with your friends and then we'll begin this session. Only 10 questions I have for you in today's session of prediction series. Okay, thank you Vishnu, thank you Arun and Hemang. Okay, everyone is here now. Okay, you can quickly just hit the like button to the video and without wasting any further time, let's begin the class. My name is Joshit Sir. I have 4 years of teaching experience, MTech in hydraulic engineering from IIT Roorkee. Enough. Now, so this is a prediction series that we have for you, and in prediction series, you may have seen a lot of subjects already are done and some of are going to be there. Formula 1 series is there also on the YouTube channel, which will help you in revising the formula of all the subjects. Tomorrow we have the Formula 1 series class for fluid mechanics. At what time? So tomorrow, that is 26th of January. The class is there exactly at 10:30 PM only on this YouTube channel. इसी YouTube channel पे आपको मिलेगा. Apart from this, because a lot of students were asking for the verbal ability, engineering, mathematics and general aptitude sessions. So we are also here with this. 27th of January, you have verbal ability marathon. Engineering mathematics is on 28th of January and general aptitude is on 29th of January, which are going to be completed by me. Now quickly please share the video first. एक बार share करो सबके साथ फटाफट से, उसके बाद start कर रहा हूं मैं session. ठीक है? Quickly 10 क्वेश्चन लेके आया होगा आप लोगों के लिए and these questions are going to be most likely similar question या इस तरह का क्वेश्चन आपको देखने को मिलेगा in your GATE examination. So quickly just share this video with your friends. मैं भी अपने ग्रुप में डाल देता हूं जिससे कि पता चल जाए सब लोग को. मेरा ग्रुप ज्वाइन करना है तो सिविल बाय निंजा सर के नाम से ग्रुप है मेरा. You can join it. कोई सवाल वाल पूछना उसमें पूछ सकते हो आप लोग. ठीक है, मैंने तो कर दिया भाई. अब बढ़ते हैं आगे पहले सवाल की तरफ बिना ज्यादा वक्त को जाया किए हुए. ओके, सब कुछ सेट है, स्टार्ट करें. सुपर. चलिए पहला सवाल आपकी स्क्रीन पर है. फॉर अ टर्बुलेंट बाउंड्री लेयर द वेलोसिटी प्रोफाइल इज डिस्क्राइब्ड बाय 1/5 पावर लॉ. What is the ratio of displacement thickness to the boundary layer thickness? So quickly please try to answer. They are asking you turbulent boundary layer you are having and that velocity profile is described by 1/5 power law. What is the ratio of displacement thickness to boundary layer thickness? So what is the relationship or what is the expression for determining the displacement thickness? So displacement thickness is generally denoted by del star and it is given by 0 to del integration 0 to del 1 minus u by u infinity into dy. Correct? Now only one thing you need to crack here. बस एक चीज crack करना है. And what is that? That is the velocity profile. They have already mentioned you in the question that u by u infinity is actually given to you already. How it is given? It is given as कैसे दिया हुआ है? It is given as y by delta power 1/5 because they have said ना 1/5 power law follow करता है. And that's it. बस इतना सा ही था. Now quickly solve it and tell me what is the answer you are getting. Everybody. चलो भाई आलस किधर, अभी एग्जाम आ गया, फटाफट से quickly solve this question. So if I do this quickly for you all and you also do this with me. So delta star can be given as 0 to delta integration 1 minus y by delta power 1/5. Right? And इसका भी क्या करने का है? Differentiate इसको integrate करना है. You are integrating this. So when you integrate this, what you are going to get? This one will be y minus, ये कितना बचेगा? This will be y by delta या y की power 6/5. Yes or no? 6/5 by delta और नीचे 6/5 तो 5/6 you will get here. Here you have the limits from 0 to delta. So when you solve this, what you are going to get over here, everybody? कोई तैयारी नहीं हो रही है भाई, कोई तैयारी नहीं है. इतना आसान सवाल का जवाब अगर नहीं आया, मैं बोल रहा हूं कोई तैयारी नहीं हुई है. ध्यान देख लो भाई, क्या कर रहे हो यार, इतनी मेहनत से इतना पढ़ रहे हो उसके बाद भी गलती हो जाए तो क्या फायदा. This will be del by 6. Very good. But we don't need this. We need del star by del, and that is 1 by 6, right? 1 by 6. Super. So option C was correct. And who has given the right answer? Hemang, Pawan and Kiran. Very good, guys. Very good. Amazing. Moving on to the next question. The next question is, a fluid film is formed in a rectangular ring chain. Okay? Rectangular ring chain you are having. A slider is located at the one face of the rectangular ring. The width of the channel ring is 0.7 meter and slider is displaced by 0.25 meter. The surface tension of the fluid is 2.68 Newton per meter. Find the work done by displacing the slider in joule. Take one surface only. So you don't have to multiply it by 2. You have to only consider one surface. Why? Because whenever this fluid film type of question comes, there are basically two layers, two surfaces. Two surfaces means double surface tension. But here they are already saying only consider the one surface only. So let's try this question, everybody. Chaliye फटाफट से everyone. So width is given to us already as 0.7 meter. Very good. How much we have displaced? The slider is displaced by 0.25 meter. What we need is, we need the work done. क्या होता है work done? Very good, everybody. Work done is nothing but force into displacement. ठीक है? Force into displacement. Force will be क्या? Surface tension into width into dl. So surface tension, how much it is given? 2.68. Width is how much? 0.7. And how much displacement is there? 0.25. From here, how much you are getting? 0.47 joule आया होगा, and that's the right answer, which is option B. Amazing, superb. किरण and हेमांग, बस यही दो लोग जवाब दे रहे हैं. ठीक है, देख लो बाकी सब. A block wood 2 meter long and 2 meter wide and 1 meter deep is floating horizontally in water. If density of wood is 800 kg per meter cube, then the volume of water displaced will be how much? इतना छोटा क्वेश्चन है. I had to just consider one question from this chapter. That is the reason why I have it here in the slide. Please answer this question, guys. Displaced volume you need to answer. Rajesh said C, that is 2 meter cube. Okay. बाकी लोग क्या कह रहे हैं? Kiran saying 3.2 meter cube. Very well. Let's check. So fundamental is very simple, that weight of body should be equals to buoyant force, correct? So weight of the body will be how much? That is rho, density of the body, g, volume of the body, equals to how much? It is going to be density of the fluid. What fluid we are having? Is it water? Yes, it is water. Into g into displaced volume, whatever volume we have displaced. Now, how much is the density of the body given? It's 800 kg per meter cube. G तो cancel ही हो जाएगा. Volume of the body would be how much? 2 into 1 equals to density of the water is 1000 into displaced volume. From here, the displaced volume will come out to be how much? That should be equals to 3.2 meter cube. Very well. Next question. Air flows at 9 meter per second past a smooth rectangular plate 0.5 meter wide and 5.5 meter long. The turbulence level in the oncoming stream is low and that transition occur at Reynolds number 5 into 10 raised to the power 5. The kinematic viscosity and density of air are 0.15 Stokes and 1.24 kg per meter cube. Now, the total drag force when the flow is parallel to the width is how much Newton? Answer please. यार आवाज थोड़ी सही सी नहीं आ रही, मुझे ऐसा लग रहा है. हेलो हेलो हेलो. पहले तो मेरे खुद की तबीयत खराब, ऊपर से ऑडियो में कुछ तो दिक्कत. आप लोगों को क्लियरली आ रही है ऑडियो मेरी? सभी स्टूडेंट्स को आ रही है तो लाइक कर दो, हम भी देख लें. बहुत सारे लाइक, मौका दो हमें भी. ठीक है, फटाक से आंसर देंगे. Everybody quickly answer right now. Tell me how much is the value. Okay. So airflow is 9 meter per second and rectangular flat plate you are having width इतना है. एक बार रेनॉल्ड्स नंबर निकालते हैं, लोकल रेनॉल्ड्स नंबर. ठीक है, एक बार लेट्स फाइंड आउट द रेनॉल्ड्स नंबर. एवरीबॉडी देखना जरा कितना आ रहा है फॉर दिस. Width, I hope you know that here the length is nothing but the width only, across the flow is happening. So here what is going to happen is that your Reynolds number will be how much? It will be generally mu VL by rho or rho VL by mu, right? Rho VL by mu. But here kinematic viscosity is given. So VL by nu we can do. VL by nu. Velocity here is how much? It is 9 meter per second. And length will be 0.5. Kinematic viscosity is given to you as 0.15 stoke. We'll convert this into CGS unit, that is minus 4 से multiply किया. How much is this? This should be 3 into 10 raised to the power 5. Is it? Yes. Now we can find out the value of the coefficient of drag. Coefficient of drag कितना होता है? 1.328 because this is laminar. For laminar this is the expression as per Blasius. Blasius ने दिया था ये, मैंने नहीं दिया है. 1.328 by under root your local Reynolds number, that's 3 into 10 raised to the power 5. From here CD should be 0.00242. Please verify if that's correct. Once drag coefficient of drag we have got, the drag force can easily be found out as half CD rho A V square. So A will be how much? 5.5 into 0.5. Density will be 1.24. Velocity is 9 meter per second, so 9 square. This should be 0.3342 Newton, and that's your answer. 0.3342 Newton should be the right answer. आया? बहुत बढ़िया. आगे बढ़ेंगे. अच्छा, another good question. Please answer this, everybody. What they are saying? Yeah. So two different fluid flow over an identical plate. Very good, Kiran. Two different fluid flow over two identical flat plate with the same free stream velocity. Both fluids have the same viscosity, but function is, what is this? I do not remember in questions. No, that's what you have to think of. What they are saying. Read the question once. I want to improve this mistake of yours. The turbulence level in the oncoming stream is low. Transition occur at RE5 into 10 raised to the power 5. They are telling you this is the Reynolds number at which transition occurs. Basically what they are trying to say कि इससे पहले आपका laminar flow है. You have laminar flow before that 5 into 10 raised to the power 5. Now you have to find out the Reynolds number. Then if it comes less than 5 into 10 raised to the power 5, you can say this is your laminar flow, and as per that you can choose the Blasius solution relationship which is required in the question. Okay, this is the question, everybody. Try to answer this now. Okay, sir. Consider flow to be laminar here. So again they are asking drag force for first to second plate will be how much? That's what they are asking. So density, basically they have given the density of the first fluid is twice of density of the second one. Dynamic viscosity is same, right? U1 and U2 are also same. Velocity they are saying it is also same, and length is also same. L1 is equals to L2. It is also same. We know just now we have seen in case of the laminar flow, coefficient of drag is 1.328 under root REL. Right, sir? Okay. So now you can try this question, everyone, and you know that RE, your local Reynolds number, is nothing but it is rho UL by mu. Okay, that's how you can do this. So drag force of the first case by drag force in the second case. Put the values everybody and see what you are getting. So here you are going to get half CD1 rho 1 A1 U1 square divided by, भाई अच्छा क्वेश्चन है, कर लो भाई फटाफट से. Okay, very good, one answer I have got. Half CD2 rho 2 A2 U2 square. ठीक है. See how much you are getting this. Here, from here you can also get the relationship. मैं दूसरी स्क्रीन पे कर देता हूँ. Reynolds number 1 and 2, and that would be how much? Rho 1 by rho 2 only you will be having. Why? Because velocity same, length same, dynamic viscosity same. So REL1 by REL2 is nothing but 2 only. Okay, so from here eventually you will be having CD1 rho 1 by CD2 rho 2. Now CD1 by CD2 will be how much? CD1 by CD2 will be REL2 by REL1, that too in under root. Rho 1 by rho 2. And from here, this value is how much? 1 by root 2 into, this will be how much? Rho 1 by rho 2 is nothing but 2 only, right? 2 only. So eventually, from here you get the answer as root 2. How many of you got this? Pavan got this answer. Very good, very well. Sahi hai bhai. Midway, sixth question. See what they are saying. Simple the question hai, very simple. Do not make the mistake. Read the question properly and you will get the answer. Yes, Hemang, 1.414 also you can say. A pipe line connecting two reservoirs has its diameter reduced by 20% due to deposition of chemicals. For a given head difference in the reservoir with unaltered friction factor, this would cause reduction in discharge of how much percentage? Please answer. Let's say the dia of what they are saying, two reservoir. ठीक है, before and after वाला ना. Initially, let's say dia was D, and after that, what happened? 20% deposition happened, so dia must have reduced to 0.8 D. Right? Two cases we have got. Now we know, as per your Darcy's-Weisbach equation, head loss is given as, if you want to write down this in terms of discharge, FLQ square by 12.1 D raised to the power 5. Got it? From here you can make the relationship between discharge and the diameter of your pipe. How? You can clearly see that D raised to the power 5 is proportional to Q square. Or in simple terms, you can say that D2 by D1 raised to the power 5 is equals to Q2 by Q1 raised to the power 2. Yes, this relation I think you already have, because you know D2 is 0.8 D and this is also D power 5 Q2 by Q1 square. From here you will get a relationship between Q1 and Q2, and what's that? So Q1 and Q2, if you see, Q2 will come out to be 0.57 Q1. Is it right or not? Tell me quickly in the comment box. Is discharge is equals to 0.57 Q1? Yes or no? बताओ. So percentage reduction you have to find out, right? So percentage reduction will be Q1 minus Q2 by Q1 into 100. So Q1 minus 0.57 Q1 by Q1 into 100. 100 से minus कर दो. That will be कितना? 43% I suppose. So 43% is the right answer. Right? 43 is the right answer. 43%. Moving on to the next question. Okay, another question, a beautiful question. Now they are saying a 30 centimeter dia, 90-degree elbow has one limb vertical. Average velocity of flow of water through the elbow is 5 meter per second and pressure intensity is 4 kilonewton per meter square. The vertical component of force to keep the elbow in position will be how much? बताइए सर. it's a 90-degree elbow. It should look something like this, right? Let's say this is the force Fy which we are interested in. Okay, now let's put the equation here. The net force equals to change in momentum. That's what we are going to use, right, sir? Aajo. Okay, so only vertical force we need to consider. So Fy minus, here you will be getting vertical one, pressure into area, equals to rho q v is final velocity, minus initially there is no vertical velocity component, so 0. So Fy would be minus pressure is how much? Yeah, directly you can say rho qv plus pa. Get the values, everybody? How much it is? Pressure intensity is 4 kilonewton per meter square, right? So 4 into area will be pi by 4 d square, 0.3 square. Not converting into Newton, ठीक है, इसको न्यूटन में कन्वर्ट मैं नहीं कर रहा हूँ. Plus here kilonewton में with this also we will get, and how much it is going to be? So rho q 1000 into, how to get this? So velocity you have, right, rho av. So it is going to be how much? Pi by 4 3 square into velocity square, that is 5. So from here it should be 2.05 kilonewton, which is option D. Okay, next question. Come on, chalo फटाफट से आंसर देना इसका. This is MSQ question. In free vortex flow, streamline are concentric spirals and flow continuously circles the origin. The free vortex flow, the flow velocity is in tangential direction only and varies inversely as the distance from the origin. In a free vortex flow, flow is rotational. In a forced vortex flow, flow is rotational at the core and irrotational. Quickly answer this, everyone. In a free vortex flow, streamlines are concentric spirals and flow continuously circles the origin. That's correct. Okay. In free vortex flow velocity is in tangential direction only. No. In a free vortex, flow is rotational at the core and irrotational away from it. Free vortex, obviously, yes or no? Because there is no external torque applied here. In forced, flow is rotational. Yes, undergo rotation about their mass center. That's correct. So option A, option C, option D are correct for this MSQ question. Got it, everybody? Very well. Next question. A cylindrical tank of depth 2.5 meter and dia 1 meter has a hole of dia 2 centimeter at the side near the bottom. It is observed that when tank is full, jet of flow drops 25 centimeter after traveling 2 meter. What is the coefficient of velocity if coefficient of contraction is given as 0.68? Please sir, answer dijiye. Basically you need coefficient of velocity, right? So please answer. Coefficient of velocity, if you are not aware of it, it is nothing but it is actual velocity by theoretical velocity. Scenario is something like this. There is a tank. Okay, and they are saying the tank has the depth of 2.5 meter. Dia is 1 meter. Has a hole of dia kitna 2 centimeter somewhere here near the bottom. It is observed when tank is full, jet of flow drops 45 centimeter after traveling 2 meter. 2 meter is the this thing. So this is 2 meter from here to here, and this is 45 centimeter. Come on. See, you need actual and the theoretical velocity. Theoretical velocity is under root 2gh, so that you can easily get. When tank is full, theoretical velocity will be 2 into 9.81. Available head with us will be 2.5. And the theoretical velocity would be how much? 7 meter per second. Yes, sir. Acha. Now, what about the actual velocity? Actual velocity कैसे आएगा? Do you remember the expression? I have derived it also so many times in my class. Actual velocity is x under root g by 2y. X is 2 meter, g is 9.81, 2 into y is 0.45. The velocity would be 6.603 meter per second. Now from here you can get the coefficient of velocity. That would be 6.603 by 7, and that is 0.9433. So the right answer would be option B. I think this is the first question that no one was able to answer. Good and bad, both altogether. Last question, a pipe of diameter 200 mm. Now I am expecting everybody to answer this question. A pipe of diameter 200 mm carries water in turbulent flow. The velocity of water at center of pipe and 50 mm from center of the pipe are 3 meter per second and 2 meter per second respectively. What is the shear stress at wall of the pipe? If you remember, you can find this with the help of shear velocity. Shear velocity is shear stress at wall by density. Somehow if you can get the shear velocity, you can get the value of shear stress at wall. This relation you can use to find out the value of U star. Here, sorry. So put the values 3 minus 2 U star by 5.75 log base 10. Y will be how much? Capital R minus small r. Capital R would be how much? It would be 100 mm. 100 minus how much? Or you can say 0.1 minus 0.05. So Y value would be 0.05 meter. So put the value 0.05 divided by radius will be how much? 0.1 only. Put the values and get the answer. Kita 3333. Okay. How much is the value of U star from here? I think it should be 5.578. Is it? So let's put the value. So 0.578 is equals to tau naught by rho. So tau naught should be equals to 334.08 Newton per meter square, which is option D. Very well. Another information, tomorrow we have fluid mechanics formula revision class. All the formulas I'm going to make you revise tomorrow, which is 26th of January at 10:30 p.m. Apart from this, on 29th of January from 10 a.m. we have this session on general aptitude, complete PYQ in one shot on this YouTube channel. So don't miss it. And if you want this PDF, it will be available in the Civil by Ninja Sir Telegram group. Thank you so much for joining the session. I hope you all enjoyed it, and I'll see you in the next class now. Thank you so much. Have a nice day. Bye bye. Take care. ले लेना PDF ग्रुप में मैं इसको पोस्ट कर दूंगा. Okay. Tomorrow, formula revision class.